In our lesson today, we're going to continue looking at proportional and non-proportional relationships in tables. We have to ask ourselves, how can you distinguish relationships that are proportional from relationships that are not proportional? And in the box, we need to remember that proportional relationships between two quantities means that they have equivalent ratios. Equivalent ratios. Which means that they have a constant unit rate. Equivalent ratios or a constant unit rate. Constant unit rate. So if there's a constant unit rate, the relationship would be proportional. Non-proportional relationships between two quantities means that they do not have equivalent ratios. Do not have equivalent ratios. Equivalent ratios, which means there is not a constant unit rate. There is not a constant unit rate. So if you do have a constant unit rate, the relationship is proportional. If there's not a constant unit rate, then the relationship is not proportional. And the constant unit rate is found by simplifying each ratio. Simplifying each ratio. We need to remember that a unit rate is a ratio that has a denominator of 1 unit. And so in our first example, we're told that a computer programmer charges customers per line of code written. And what we need to do is determine, is this relationship going to be a proportional relationship or a non-proportional relationship? And we have to think about how we want to set up our ratios. Do we want codes per dollar or dollars per code? Well, in this example, we're told that the programmer charges customers per line of code. So for our ratios, we're going to do dollars per line. Dollars per line. So we're going to take the information from the table. In the first set, we're told that it's going to cost $1,000 for 50 lines of code. And we want to simplify that down and figure out how much is it going to cost for 1 line of code. So we're going to have to do 50 divided by 50 to get 1. 1,000 divided by 50 is 20. For our next set, we're told that it costs $2,000, and that's going to be for 100 lines of code. Well, again, we want to know how much is just 1 line of code going to be. 100 divided by 100 is 1. 2,000 divided by 100 is 20. With our third set of data from the table, we're told that it costs $3,000, and that would get you 150 lines of code. We want to know for 1 line of code, so 150 divided by 150 is 1. 3,000 divided by 150 is going to be 20. And with our last set of data, we're told that it costs $4,000 for 200 lines of code. Well, once again, we want to know how much is just 1 line of code going to cost. 200 divided by 200 is 1. 4,000 divided by 200, again, is 20. And so what we need to do here is look at all 4 of these unit rates. All 4 of the unit rates here are equivalent. They all say it's going to cost $20 for 1 line of code. And so for this data right here, for dollars per line of code, every one of them, $20 for 1 line of code. This constant unit rate is called the constant of proportionality, and it's given by the variable k. Since all 4 unit rates simplify down to 20 over 1, we can say k, the constant of proportionality, equals 20 over 1, or 20. The value of k, which is the constant of proportionality, is 20. The constant of proportionality is related to the constant unit rate, but it doesn't have labels. Okay? So the unit rate is $20 per line of code. The value of k is 20 over 1, or 20. Now we need to answer whether or not this relationship was proportional or non-proportional. The two quantities of cost to line of code show a proportional relationship. And we know that this was a proportional relationship because all 4 of the unit rates were the same. So we would say that the relationship is proportional because there is a constant unit rate. There is a constant unit rate. If we have a constant unit rate, then it's a proportional relationship. And we can even say that there's a constant unit rate of $20 per line of code. There is a constant unit rate of $20 per line of code. In our next example, we're told that the table shows the number of students that buses can transport. We're going to use the table to find the constant of proportionality, which is again the variable k, and we're going to look for that if there is a constant unit rate and tell what kind of a relationship exists. So we can look in the data in the table. We see our number of buses and we've got our number of students, and we want to set these ratios up. Do we want buses per student or students per bus? Well, I think it makes sense right here, and it says right there, students per bus. That's the way that we should set up our ratios. So students to the number of buses. Okay, and we're told with the first set of data that 144 students can fit on 2 buses. We want to know how many students would fit on 1 bus. 2 divided by 2 is 1. 144 divided by 2 is going to be 72. With our next set of data, we're told 216 students fit on 3 buses. We want to know how many fit on 1 bus. 3 divided by 3 is 1. 216 divided by 3 is 72. The next set of data says that 288 students fit on 4 buses. We want to know how many students fit on 1 bus. 4 divided by 4 is 1. 288 divided by 4 is 72. With the last set of data, we're told that 360 students fit on 5 buses. We want to know how many students fit on 1 bus. 5 divided by 5 is 1. 360 divided by 5 is 72. And so again, we can see in all 4 of these unit rates, they all simplify down to the same value. The constant of proportionality k is that value. We can say 72 over 1 or just 72. The constant of proportionality is 72. What does it mean? Well, it means that there could be 72 students per bus. Since the constant of proportionality k is the same unit rate, since we got the same unit rate, we know that there is a proportional relationship. There is a proportional relationship between students and buses. Our next table shows the number of miles a plane traveled while in flight. We're going to use this information to see if there is a constant of proportionality and whether or not the relationship is proportional. We have our time measured in minutes and we have our distance measured in miles. Do we want minutes per mile or miles per minute? Well, it makes sense in this example to set up our ratios as miles per minute. So that's how I'm going to set up my ratios, miles per minute. The first set of data says that we can go 270 miles in 30 minutes. So for 1 minute, 30 divided by 30 is 1. 270 divided by 30 is 9. With the next set of data, we can go 405 miles in 60 minutes. For 1 minute, 60 divided by 60 is 1. 405 divided by 60 is 6 7/75. With the third set of data, 810 miles in 90 minutes. For 1 minute, 90 divided by 90 is 1. 810 divided by 90 is going to be 9. With our last set of data, we're told that we can go 1,215 miles in 120 minutes. For 1 minute, 120 divided by 120 is 1. 1,215 divided by 120 is 10 125,000ths. Okay, so we look at our 4 unit rates this time and we see that 2 of them are the same, but in order for the relationship to be proportional, all 4 of them have to be the same. Not all 4 of them are the same, so the relationship isn't proportional. If the relationship isn't proportional, then k, your constant of proportionality, doesn't exist. And so for k, we're just going to write n/a, meaning not applicable. It doesn't exist in this example because the 4 unit rates were not the same. Is there a proportional relationship between time and distance traveled? Well, we would say no here. And the reason, okay, we would say the relationship is non-proportional. The relationship is non-proportional because there is not a constant unit rate. If there is not a constant unit rate, then the relationship is non-proportional. In the next example, we're told that the table below shows the hourly charge to rent a bike at Supercycle's bicycle store. We need to find the constant of proportionality if it exists, and we're going to do that by setting up our ratios. We have our time in hours, our cost in dollars. Do we want hours per dollar or dollars per hour? Well, the store charges dollars per hour, so that's how we're going to set this up. Dollars per hour. First set of data, we're told that it costs $24 for 2 hours. For 1 hour, 2 divided by 2 is 1. 24 divided by 2 is 12. With the second set of data, we're told that it costs $36 for 3 hours. For 1 hour, 3 divided by 3 is 1. 36 divided by 3 is 12. With the next set of data, we're told that it costs $48 for 4 hours. For 1 hour, 4 divided by 4 is 1. 48 divided by 4 is 12. And for the last set of data, we're told it costs $60 for 5 hours. For 1 hour, 5 divided by 5 is 1. 60 divided by 5 is 12. The constant of proportionality in this example, K, equals 12 over 1, or 12. It means that it costs $12 per hour. Since all 4 of these unit rates are the same, we would say that the relationship between cost and time rented is a proportional relationship. A proportional relationship. In 4B, we have another table of values for another bicycle store. This one is Pedals Rentals. And again, we're trying to see if there's a constant unit rate and if the relationship would be proportional or non-proportional. So we're going to set up our ratios the same way, dollars per hour. And with the first example, we're told that it costs $4 to rent a half an hour. $4 for a half hour. Well, we want to know how much it's going to cost for 1 hour. A half divided by a half is 1. 4 divided by a half, which is the same as multiplying by 2, gives us 8. The next set of data says that the cost is $8 for 1 hour. This is nice. We don't have to do anything because the unit rate, we can tell this is a unit rate already because the denominator is a 1. So we'll move on to the next set. It's $12 for an hour and a half. Once again, we want to know how much is it going to cost for 1 hour. Well, 1.5 divided by 1.5 is 1. 12 divided by 1.5 is equal to 8. And with the last set of data, we're told that it costs $16 for 2 hours. For 1 hour, 2 divided by 2 is 1. 16 divided by 2 is 8. So again, I look at all 4 of the unit rates. They're all the same. The constant of proportionality K is equal to 8 over 1, or 8. It means that it costs $8 per hour to rent a bicycle at this store. Since all 4 of the unit rates are the same, we would say that the relationship between cost and time rented, again, is a proportional relationship. Since all 4 of the unit rates are the same, there's a constant unit rate, the relationship is proportional. Our last question asks, which bicycle store charges more per hour? Well, we just saw at this store that it's going to cost $8 per hour. And if we go back up above at our first store, our constant of proportionality was 12, which means that it costs $12 per hour. So, which bicycle store charges more per hour? Well, it's going to have to be Supercycles, since they charge $12 per hour, and Pedal Rentals only charges $8 per hour. So, which one is more per hour? It's going to be Supercycles. Supercycles.